kind of nice to be back after a few years and see folks and technologies and friends that I haven't seen for a few years. Often when I've been talking the last few years, I'm never quite sure if I'm preaching to the choir or the unwashed masses. Today, it's definitely preaching to the choir. But after this morning, whatever Director Cardillo said, and pretty much done, I'm going to echo a lot of those themes here today. Again, I'm Terry Busch, and subject today is some of the innovation we're doing at DIA, and what relates most to the GEOINT and the GEOINT community is this concept of foundational intelligence modernization, and I'll sort of explain what that is, where we're going, and where the innovation lies, and where we need this community's help, which is the main reason we're here today. Foundational intelligence modernization is really one of the most important goals we have at DIA right now. We face, just like everyone else, the same problems of scalability and moving out at a much rapid pace, becoming a data-driven organization, yet not able to increase staffs, budgets, technology decks. It's not going to come through infrastructure on the technology side. It's really going to come through open source and on the big data side. One of the keys to that is how do we address those challenges? And so what we did is we went back and we built a plan around foundational intelligence modernization, recognizing that much of the data growth we're looking at is not just orders of magnitudes, but unimaginable scope as we reach out. So that transformation is our goal. Excuse me just a second here, I'm trying to get back on the slide. Go down one here, there we go. So one of the things we wanted to do as we went through the process is not look at a technology deck, not look at the big data and say, okay, what are we going to pick and choose from the menu here? But identify our own business process first. How do we do business today? And then how do we transform it was the key to behind what we want to do with foundational intelligence modernization. It's probably the first time we've ever taken that approach, and in our belief, it's really helping to pay off. Once we've done that, we look at those culturally challenging environments. We have to create an environment, as we do foundational intelligence, where we're not going to say, hey, we're transforming the agency to new decks of technology, new cultures of technology. Rather, we want to say, we're going to enable you to do your job better and easier. And that's really at the core of what we're talking about here today. It has to be accessible, and it has to be a bottom-up approach. We have to go foxhole to foxhole as we do this. The issue here is that it's the same problem we've always had. When we look at our analysts, and as I go forward here, gray is old and blue is new, our analysts are still spending too much time in data development and not enough time in analysis. The analogy I use is we have to let our surgeons be surgeons. And if Charles Rowland were standing up here 10 years ago, you would have seen this same slide. Everything we've done with DigiNet and Diagram and all the other programs and technologies you've used through the years is to enable our analysts to be more efficient. It's the same goal with foundational intelligence modernization. We have to flip that, invert that triangle to give them time and efficiency, yet wow, how are we going to do this when they're looking at all this new data? A second here. So when we broke down that business process, it really came into three loops. First is a database loop, second is an analytical loop, and the third is a production loop. If I were to go to any of the ICs out there, or almost any government office, it would break down in almost the same way. So this is just how we have arrived at this place in time. The problem is these loops tend to work statically, and many of you will agree, right? You collect your data, especially in a GIS context. Now I've got my data, now I go to analysis, and I've done my analysis, but I'm ignoring that there may be new data. And then I go to production, and then I go to an even more static environment. And there's no interactivity between those loops. And one of the things we want to create here is the ability to tie all this together. So I'll break into some use cases as an example, but again, bearing with me here that gray is old, blue is new. This is the way we looked at it. So in the old way, we did, and we're all source kind of guys, we used that all source information. We gathered those traditional sources together. An analyst would vet that data, bring it all together, right? He would assess all the information, and that vetted data would go forward into a database, MIDB, something like that, right? And on the foundational side, This is a key to it. And this is really, for those of you not familiar with the business process, we're really talking about a databasing effect here, right? Not that sexy, but very, very valuable to the defense intelligence enterprise. So here comes big data. So what are we going to do about it? Well, the first thing we're going to do is go get it. When we look out at the big data world, we see location-based services exploding, just absolutely exploding out there. And we see, I won't name all of these by name because I haven't talked to some of these folks to clear it here. One service adds 1 million new places of interest per day to their database. Another service uses 1 trillion data points to do location-based services. The data is there. Everything in the world is being named, just out there by the general internet, and it changes the way we do our job. Now, the hard targets are still the hard targets, and we won't discuss those here. But a lot of those things, especially in the foundational world, are already out there. They're just there for us to go get. So what do we do about that? Well, the first problem we have is it's more data than we can ever conceive of. So at the bottom there, we recognize we need this community's help because there are correlation engines that have to be built. There are conflation tools like Hootenanny that have to come into play, convolution engines that come into play. That is the technology that we need to begin to identify because some of the data is going to come, hey, if Google and Apple and MasterCard are using that and say that's a place of business, I can use it too. I have high confidence there. But if it comes out of lower level tiers of data realms, well, maybe I can't use that, or maybe I have differences in what they think about that place. So we have to find some way to bring all that data together. The next thing we do, it's far too much data to put an analyst eyes on. And this is probably the hardest cultural change, is getting the man out of the loop here. But what if, in that correlation process, I said, you know what I'm going to do? I'm going to put a confidence interval against that data, and I'm always going to let you discover the provenance of the data as I look at it, right? So you, the analyst, can always look into the data, but it's far too many bridges, roads, helicopters, ice cream stores, whatever, for any human being to go and look at. And if I bring that data forward, I autonomously validate it, I grab as much data, metadata and attribution as I can on the way in, and I stick it into a lesser vetted attributed database, it's right there. Now I have the data, I have it pretty well organized, although I don't really care about perfect schemas and ontologies and taxonomies anymore. I'm getting data that's going to be dirty, and I'm going to live with that. That's fine. But what I really have now is a lot more data so I can get down to brass tacks when I need to. If I find that data has value and its importance, I can bring that data up and say, okay, now it's in my important vetted databases, but I have it ready to go on the other side. The next cultural problem I face here is analysts want to keep the control, right? They want to control the methods of their data. So we said, okay, how do we address this? Well, the key here analyst isn't reviewing point by point anymore. They're looking at data in a streaming method, right? They're saying, boy, that data is pretty good. I want more of that. I want less of the data here. Well, at first blush, that seemed kind of hard, but what we've been learning, and we've been playing around with a lot of machine learning here, is machine learning's fantastic for this, right? If I take this data and I tell machine learning, I like this, but I don't like this, it says, okay, I'm a good dog if I get this, and I'm a bad dog if I get that. And it uses both sets and it goes. And the accuracies we get when we bring machine learning into the process are just off the charts of what we've been able to do. So that part of the engine is where we have the highest level of confidence that we'll be able to do this. And the levels of accuracies we're getting off of some of our big data scores, we're getting recall rates over 95% on data accuracy. I don't want to disparage anyone here, but that's probably better than some of our human beings can do. A couple examples here of encouraging technologies, right? So I say, oh, the big data is out there, Terry. Yeah, but is it there when you need it? Well, one of the technologies we love is Digital Globe's TomNod, right? So there's 2 or 3 effects going on here, and I just want to spend a moment to talk about it. Like, put your money where your mouth is, Terry, here it is, right? So they can go in and crowdsource imagery exploitation, right? If it's a very simple target, like much of foundational intelligence is, they can have a crowd combined with the commercial imagery. Now, the crowd isn't doing all the imagery exploitation. Remember I mentioned the machine learning earlier? The crowd is really training the machine to tell it what to go look for. So once the crowd starts to build up its confidence in finding a damaged building or things like that, off to the races we go. You've seen this effort with the MH370 in Malaysia, Nepal earthquake, and other examples here. And so what I like about this is I can spend my time mining data out of big databases, but where I really get into a jam is in a crisis, right? Something's gone wrong in the world, and the military is going to be a first responder is a great use case. Wow, we're going to Haiti tomorrow. I sure hope those OpenStreetMap guys have something, because we don't have the ability to turn on a dime light. This gives me the ability to target that or use that volunteer geographic information to get the data I need in a hurry, in a very active sense. And again, the second part of this and the third part of this is that machine learning. It's not just the crowd, it's that the crowd is validating the target. And sort of the third part of this is we have a very well-developed expert model behind this, which is evaluating our crowd. You may get a few jokers in the crowd who are going to start calling telephone poles, ice cream stores, and just to screw around. We can very quickly move those guys out. And one of the things, and Chad Shuey is always famous for saying to me, is over time the crowd outperforms the expert. Absolutely true here. And here's the Nepal earthquake data. There's, think of the resources. This was a volunteered effort, right? Think of the resources our community would spend to find all of this damage, right? All of those points. Yet, here it is being done in a volunteer sense for free. Very important concept when you look at big data and moving forward. So there was a result, oops, sorry, go back up one. There was a result of what Tom Nod was able to find in just 2 or 3 days, right? So very, very quickly, boom. So I almost call it a swarming effect more than a crowd effect of what's going on here. Now this is when people are incentivized to go and help. When they're not incentivized to go and help, there are other models that come into play, and we're very excited about those. The other data set that's similar in theory to that is sort of what Spatial Networks is doing with the Fulcrum app, which is turning this from an overhead situation into a mobile situation, which I really, really like. As technology, mobile technology proliferates across the world, why not use that data? Why not have that as an information source that we can leverage? So this is really, really nice. And it's, whereas TomNod has really shown its value in a crisis thing, we can look in here, and as this technology and these kinds of technologies proliferate, it gives us a way of seeing and a way of knowing, again, at a very low cost, in a voluntary sense, in disparate places in the world where it's often hardest to get the data. And there you can see sort of what the mobile version of that looks like. So when I talk about the databasing side of this, it's just a few samples of what we're looking at. Sure, there's the multi-billion point databases, but these technologies allow me to go from a passive collection in that regard to an active collection, which I really, really like. The second and probably increasingly controversial part of this is, so now we have our data machine working. It's funneling the analyst data, it's streaming it in, and we're in good shape here, right? It's coming in with confidence interval. So we have to move from old to new here, and this is our thinking on this. The first part is we still use a lot of very proprietary technology. We don't do a lot of collaboration with our methodology and tradecraft. We don't share our models, right? I've tried. We struggle to do this. But the technology, especially GEOINT technology, is maturing so fast. We're approaching a state, right, where we can do that. Because what I want to do is gain those efficiencies there. The other thing I want to start asking of you to help me build on our models is, our models shouldn't just say input results. Our model should say input, you need more data. I could do more on that network up there, Terry, but you got to go collect it. Go back to your machine and see if we can go get it, right? We have to start building in that level of interactivity of what we're doing. The next thing we need to do is sort of chunking this out. And I find the right terminology is elusive here, but getting our technology to an agnostic state where I can pull a geoprocessing service from here or a correlation service from here and combine those together to build something new. And that logical relationship exists, and I press a button and it goes. What I have to do at DIA, given the diversity and the extent of our mission, is make all that happen inside whatever technology realm you're already working in. I cannot ask our users to say, oh, throw out the baby with the bathwater yet again, we're going to move over here to this new technology. I have to ask our users to say, I'm going to get more data in the environment that I'm in. And I need your help to help me make your technology get there as we go through this. It's a tough order, but I think I have some solutions to this. And again, all this flows back into the loop. So one of the reasons I'm high on this is my good friend Sean Gorman and his company Timbre looks at, is a good use case of how that might work, right? So here's 72 hours of Gamergate that Sean collected, right? So he's got the neural network built. He can see the connectivity during that very controversial event, right? So what he can very quickly mind is that serial users, serial abusers, the guys that are out there throwing the hate on the social media, they get banned pretty quickly. They get blocked. They lose their accounts. All they do is they spawn off new accounts. So the very first thing he can do is, in a very live streaming sense, he can identify this pattern, right? The next thing he can do is begin to build the networks and the relationships out. He's modeling this, right? And ultimately, he can come out and show where those relationships are and show that there's an interconnectivity. There's some relationship between the guys throwing the hate and the rest of the world out there that he can sort of model. What I love about this, and hopefully I can pan down here, go back up here. What I love about this, and this is where I get to, so he looked at the data streaming live. He built an analytical model around it, invoking open, already available technologies. He essentially went to the library of services and did a little light coding himself, and then he published this as a web service without any commercial technology in the loop. This is entirely an open source analysis capability done very, very easily. What's really cool about this is then it's an IPython script at the end of it. So you can take this and say, wow, this is a crowd effect I'd really like to use for my use case over here, modify the Python script and go. So he's not only does he have an open source and an agnostic, but he's got a collaborative effect to what he's doing. And this is where I want to go with analytical tradecraft, where we're doing that level of sharing. So I don't have to continually write mobility model after mobility model year after year. I can use AGCs because theirs are really, really good. The other thing is, sort of as we get into this realm, is the analytical world is already creating us new ways of knowing. For years, those of us who looked at population densities and that kind of data was a rough, really pretty coarse data that was collected. It was a good methodology, but instantly if we begin to mash one data set against another data set, we can make new discoveries and go to this higher level of granularity that's required to meet the future foundational mission. And so here's Digital Globe showing you that they can get population density down to 50-meter cells, which I really, really love. Here's new friends of mine at Openware doing anticipatory location information, taking all that data in a live streaming sense, bringing it together, and publishing it out as a web service, right? And doing analysis telling you, look here, or if something is developing there. Really, really great technology deck that they're working with there. So the third and final part of the loop is a production loop. And I use a map because obviously I'm a map guy. So what if we took that analysis and we brought it forward? We also give it its own confidence interval. Is that mobility tool any good? What's its provenance? Who uses it? Along with the data and its confidence interval. So we bring that into the production environment. But we've got to leave the PDFs. So we've got to leave the PowerPoints and the static products behind. So what I really envision is a world where it's a collaborative environment, because what I want is our customers interacting with their data. Oh, gee, how did Terry's guys get to that answer? Let me look at that data. Let me look at the model that they did, and bringing those two worlds together. This is an area where the geospatial community has done a very good job. We have map story maps. We have technologies now that are showing the map as the narrative, which is a great way to deliver intelligence as a story. We want more of the map as a collaboration tool here, because most all-source data organizes very well in this regard. I sort of missed this point earlier on, but to us, and the power of GEOINT is that GEOINT is the best organizing principle for data that we've ever seen. To us, if the data is geospatially enabled, we can automatically lay hands on it, right? It automatically runs for us. We don't have to worry about much. In fact, data interoperability is something your community solved a decade ago. We don't even worry about that anymore. So as we look towards collaborative technologies to bring the end user together with a customer, this is where we want to be. So this is where we need more innovation. This is where I come here today asking for your help. We're demonstrating how important the map is. In the narrative, we need that collaboration tool. Databases are going to get dirty and ugly. We're already in the NoSQL world. We're already in the schemaless world that we work in, and the data we're going to see in the future is going to be more like that. We are going to rely on that lat long, on that geo property is the one unifying theme for all of this new data as it comes in. Very, very key to us. Very, very key for the databases like MIDB, Gossip, Gale, Fishnet, Mesa. Those data is the types that you guys use that are out there. We do believe we're approaching a more agnostic shared technology community. It's great from a government perspective because it sure looks cheap, and I'm a big cheapskate, but I worry about how that's going to affect our commercial sectors and how would people profit in this model where every model is shared and thrown on GitHub. It's great, we've been using Mr. Geo for years, and hootenanny we love, but we also have to understand here that there's a lot of investment made in these worlds, and I'm not sure how the business model exactly works out there, but you can see with Sean's example where we can mash this together in almost real time where we're headed there. And then finally, the new darker realms of artificial intelligence, deep learning, machine learning, graph databases. These are powerful ways to go and interpret this data in exciting ways. And that's where so much of our attention has begun to turn, and our early results are off the charts positive in what we've been able to do here. So we're highly encouraged, and it's a new approach, right? Rather than using expert model, the machine is just training, right? The machine is training and saying, okay, I have 10,000 images of Terry's Toyota Camry. If Terry's Toyota Camry shows up on a web page somewhere, I'll be able to find it for him, right? That's really, really cool stuff that we're excited about. And again, that's sort of more back at bowling. So coming back to the original concept here, just a few use cases here, is all the arrows start to begin to make sense, right? One version of our business process affects the other versions of our business processes. We think this is entirely doable. Probably as you go to the right, there's technology yet to be made, but we want that high level of interactivity because we do this in a very static sense today. So a couple years ago, previous director, General Hughes, or 2 directors ago actually, used this term at this conference. He says, GEOINT is the common ground that ties us all together. And that's kind of what we're saying here is that ability to enable our data in the geo world and from an all source perspective is a unbelievably powerful concept. As we probably do less geo work than we used to because of the success of this community, but it is still very important to us in all of our data concepts. When we look at foundational, we really think it's a driving force in how we're going to be successful and why we have high confidence in what we're doing. So that's a really quick look at what we're doing today. Again, I can talk about the technologies briefed here, some other technologies if you'd like. We just wanted to sort of demonstrate, if you invite me back at some point in the future, we'll tell you whether we were successful or not or whether we failed miserably. Thank you very much.
Thank you, Mr. Busch. I've got 3 questions here from the audience, and then we can open it up beyond that. First question is, I think you went through a definition of foundational intelligence at the beginning of the presentation, but one of the folks here noticed that human geography was not mentioned. And there's a question around, has that been de-emphasized with the change in management at DIA?
No, Nicole Spinaga would kill me if it was de-emphasized. No, we have a division focused on leveraging human geography for all sorts. DRI 8, my sister division, it's very important to us. It is as we become a data-driven industry, it's a hard concept to put your arms around in a data construct, and the people who do that are really, really good. But from where I sit, it's a complicated, it's a heterogeneous world, and it's awfully hard to map, as those people who know do it. Definitely not out of our definition here.
Okay. All right. Your presentation implies that standards are critical. How does this work with eyesight? And I'll help you out a little bit here,
sure,
too, in just a thought. How does eyesight support this, or how do you expect eyesight to support what you're speaking of?
So one of the reasons we don't identify a technology base is that we know that eyesight is coming, right? So the big data work that we're doing now, and this is a key concept, 70% of big data is cleaning your data. Right? When you get your data just so and perfectly tailored, the analysis is easy. So our guys who do this, it's hard work to do, and anybody in the big data world who tells you otherwise, that normalizing your data isn't the biggest part of it, is lying. The second part of this, and this is the difficult part, is to go from our security and intelligence constructs against this kind of world. Because when we're doing that normalization, we're error coding on the fly. The data's streaming in, all of a sudden the data starts throwing an error, and we have to write code against that. That doesn't work well in a world of security accreditation and cell-level security and all this sort of stuff. We have to find the balance where we can work in unconstrained technology environments, yet get the degrees of freedom there. So that line is moving all the time, and we're trying to work through that. The good news is we have lots of good data to work with and lots of good mission use cases.
What slows down the application of innovative technologies, both in industry and at DIA, your opinions, both for industry and DIA, and then what can be done about it?
Okay, so I'll speak freely here. First, we have to learn to fail wisely. We have to learn to fail a lot. So the thing that we like to do is empower analysts, but understand that we want to encourage that risk for them to fail. So being a technology cheapskate like I am, pretty easy. When we fail over a few $1,000s because we're not building a lot of multi-billion-dollar platforms, so that's easy. The second thing is we have to do a better job of transitioning to a data-driven culture. So we have data science communities developing, we have all these new techs developing, but at least in my perspective at DIA, we still have an analog culture that needs to move over. And that's going to be part of the driving force. So for us, the solution to that is analyst next to developer. You'll find in DRI 7, it's a running joke because they say, oh, intelligence analysts need language. And we say they sure do. They all need to be able to script in Python. That's kind of the state we think we can get to adapt more quickly. But we need those permissive environments.
Any questions from the audience? Okay, thank you very much.
Thank you.
Thank you, Mr. Busch.